Hi everyone, my name is Anthony. I'm a computer engineering student at the UB, and this is my presentation for the core Geology 205 with Dr. Hamad, and I'm going to introduce the concept of plate tectonic. Tectonics is basically the study of large-scale movement and deformation of the Earth's outer layers, lithosphere, and the theory of plate tectonic is recent and explains the structure and development of the Earth's crust. And plate tectonics postulate the existence and movement of rigid plates over a partly molten layer in the Earth's upper mantle.
So first of all, what are the layers of the Earth? We have the crust, the upper mantle, the outer core, and the inner core. The lithosphere is just here. And it's basically the outer solid layer of the Earth. It's formed of the crust and the uppermost mantle. It's rigid, made up of plates that move in relation to one another over the weaker asthenosphere. So the asthenosphere is basically here. The asthenosphere is the hotter upper mantle below the lithospheric plate. It can flow like silly putty and is a viscoelastic solid and not a liquid. But the lithosphere is a solid part of the Earth. A force applied to a rock is called stress. We have compressive stress. We have tensile stress. And we have shearing stress. When the stress increases, we have first the elastic region, where the rock has a temporary strain and object recovers original size and shape once the stress is removed. We have the plastic region, once elastic limit has been exceeded. And at the end we have the fracture. It's the rupture or a break of the rock. So the physical behavior of rocks is affected by 1. The temperature, and 2. Pressure. There are 3 types of plate boundaries. We have the divergent plate boundaries like ocean spreading ridge, convergent plate boundaries like subduction zones, and transform boundaries. Now let's study the movements of the tectonic plates. We have a divergent boundary just right here. It's an ocean spreading ridge. So we have a divergent movement, and here we have subduction, same for here, 2 subduction zones, 1 divergent zone. We'll have the melting of and the creation of magma here, here, and here. We will have volcanoes right here, but it will be peaceful volcanoes because the temperature is higher and the silicon content is lower, and the volcanoes formed from the subduction zones will be explosive volcanoes and dangerous volcanoes because of the high silicon content due to assimilation and the melting of the continental crust. So we can find felsic rocks here, which is a type of igneous rock high in silicon content, and with the increase of temperature we can find more mafic rocks here, and then ultramafic rocks at ocean spreading ridge. After the subduction, the lithosphere will enter the mantle of the Earth, and we'll see an inward movement and formation of magma right here. Now you know better about the movement of continental plates and oceanic plates and the formation of volcanoes, and thanks for watching.